Welcome to this 5-minute long presentation on our new technology, which is the reference now for mass serialization in glass and other transparent materials. We are a Belgium-based company based in Liège, and we have a production area of over 1,000 square meters with dedicated testing areas and application labs. We are experts in all types of lasers from diodes right through to femtolasers, and today's presentation is concentrating on our new technology called Trackinside for the femto laser. In the pharmaceutical industry, there are mainly three areas of problems, which is the product mix-up on production lines, counterfeiting in the market, as well as grey marketing. And all of this results in the loss of revenue and profit and brand equity and then possible lawsuits. Our concentrating at the moment on vials and syringes. We use a 5-step proven track process where we take ownership, analyze the situation, go into testing phase, and get the key stakeholders involved, and then go right through to calculating the payback so that you can know exactly what you've paid for and how you get the money back. Our competencies range from robotics, vision systems, right through to reading, and all different possibilities, and we have lots of pharmaceutical production line equipment experience, so we are experts in industrial lasers. Our technology Trackinside is based on extremely short pulses of very high energy, and that is in fact the femto. Femto lasers are 10 to the minus 15 seconds per pulse, but every pulse is more than 6 megawatts. The result is, all we do is we change the refractive index of the glass. There are no microcracks that can propagate over time and cause cracks in the glass. We don't have any additives like inkjet or metal deposition systems. So we just mark inside the glass, and it's internal to the glass, which is also revolutionary. We can do this extremely fast. And we can do a 0.5 by 0.5 data matrix, 16 by 16 columns, 16 rows by 16 columns, and we can mark this at over 10 per second on the fly, which means the syringe or the vial can be whizzing past the laser and doesn't need to stop. The laser itself, on the right of the picture, the orange box, is similar to an inkjet printer. It can be mounted anywhere in the production line, above the production, or anywhere where there's some space, and we use the mirrors to then concentrate the beam to be actually pointing at the vials and syringes as they whiz past the laser. The interesting thing is that the marking can be read in both transmission and reflection. On the left side we have a piece of glass with the light from behind, and you can see the logo very easily. On the right side we've put the piece of glass on a grey material, and even still you can read it with the light coming from the same side as the eye or the viewing system. We have a very high readability, grade A in fact. That's because we have extremely high precision. Even when the bottle or vial is full, with a milky material we can still read it, albeit with a slightly lower grade of readability. Here's a nice example of a logo used for authentication inside the glass. And here, with thanks to Becton Dickinson, we've put it inside a syringe, here in the tube, but it can also be on the flange as long as we have enough space.